Hello and welcome to the Apache Cassandra Corner, a community-driven podcast for all things Apache Cassandra. The Apache Cassandra Corner is sponsored by DataStax. I am your host, Aaron Pletz. Hey, welcome back everyone to the Apache Cassandra Corner podcast. Once again, I am joined by Aaron Morton. Aaron, welcome back to the show. How are you doing?
Good to see you again, Aaron. Thank you for having me. I was talking with my wife the other day. I was doing this, and then I kind of sorted our names through to like the beginning of the last name. I was like, I'm still in front, right? Like still A wrong, but I've got M at the end.
So. Right. Yeah. Oh, that's funny. Yeah. So for the folks at home who haven't seen the other episode of the unit, why don't you tell us, real briefly, just a little bit about yourself?
Cool. So I've been working in and around Apache Cassandra since 2010. I started playing with it around version 0.3, 0.4 in 2010. And then in March of 2011, sort of left my job here in New Zealand, working at a company called Weta Digital, which is the big VFX house, right? The company that makes Avatar and all those things. Left there and became a professional Cassandra person in March of 2011, and there wasn't many around. Ended up with a company with a stupid name called The Last Pickle, did that for 9 years, and then joined DataStax at the beginning of 2020. So clearly knew all the DataStax peeps.
Oh, right.
Years and years. Yeah. So more than before there was DataStax and been around them. So been a committer, been on the PMC, and nowadays just do a lot of work on trying to improve developer experience and APIs and things.
Oh, excellent. Yeah. We're definitely going to get into some more about the improving the developer experience for sure. And yeah, it's interesting that you talk about it from going that far back. It's like, better than anyone about what the developer experience looked like, and say like Cassandra 1.0, when we're working with Thrift and So
to begin with, it was like, if you remember, like configuration and schema was in a file,
right?
Like find your column families. You couldn't even do create column family. You would just put it in a file, and it would load that, and you'd go, so I've got the thing. And then we had Thrift, of course. Thrift had no challenges as a project back then. It wasn't operating well as a project. But it also kind of boxed us into a corner that made it hard to even just talk about. One person explained to someone else what they were doing with Cassandra. I think that's like the thing that SQL ever did was you could say, could you look at my query, please? And someone else would be able to understand it. And then you could have a conversation about what it did versus look at my Ruby code. And then someone goes, no, I don't know how to do Ruby. So you can't get any help. So,
right. So now with the work that you've been doing, why don't you tell us a little bit about, like JSON and Cassandra and maybe about the API layer that you've been working on?
Yeah, I think we touched on this maybe back in March last time we spoke. We previewed it around the, what's it called, like Cassandra Forward that happened earlier.
Right.
Yeah. And definitely going to be talking about this at the Cassandra conference in December. Forward to that. Going back to the States for that. So, we know that JSON's a really important part of the developer ecosystem, but it's a transport. It's the things it allows you to do, the flexibility that allows you to do. That's great. And when we look at the way that people in the Node.js world work, a lot of them, and I mean a lot of them, use an object document mapper called Mongoose, which has around a bit over 2 million downloads a week on NPM. GitHub keeps on ramping the number, and I don't know if they're actually calculating this, but last time I saw it was like 3.7 million dependent repos on GitHub.
That's crazy. I had Val Karpov on the show like right after you back in March, and we talked about similar numbers. So you're telling me we had like another million downloads of that thing since? I suppose, yeah. But that's crazy.
Yeah, it's insane. But what it does, what we did is we looked at Mongoose and said, like, look, JSON has this infinite flexibility and there's all these things you can do. We need some type of swim lane to understand how people use this, how
Right.
people want to
Right.
store it, query it, modify it. And we looked at Mongoose and said, Let's make the best backend we can for Mongoose. Let's, understand has a fluent query builder attached to it called mQuery, but
Yep.
it
Yep.
talks about schema. It constructs queries that it wants to send to a backend. We can understand the schema. We can understand what's important to Node.js developers, what features are less important. We can understand the types of queries for filtering, the projections that you need to support, and and the types of update operations that it expects.
Sure.
If you're, a Node.js dev doing this, now it's going to work for Node.js, but it's going to work for any other language as well. What we did was said, if we make a really great backend for Mongoose, this will be really useful to the Mongoose people and useful to other people as well. So basically, it gave us a target.
Absolutely. Yeah.
Gave us
Yeah.
a target to aim at.
Well, that sounds super exciting. So, you know, now in order to make this API, a reality, you kind of needed some newer things inside of Cassandra, right? Some of the newer features of 5.0 um are being utilized, with this API layer, So maybe you could talk a little bit about like how you're using like storage attached indexes or like kind of like the new operators a little bit. And yeah, yeah. Could you
Yeah.
go into a little bit of that?
So we're kind of using old stuff, using old things in Cassandra and things that are new and things that will be new soon.
Hmm.
To
Hmm.
kind of going the spectrum. We created this idea called super shredding,
Right.
and
Right.
you look at the JSON document that you've given us, and we understand the types of querying, filtering that you're going to be able to run against that.
Hmm.
Right? You're going to be able to say where username equals Aaron. You might want to say contains, but find all the documents that have the human tag, the human keyword in them, but don't care about the value. You might want to do some operations, understand the size of an array and things like that.
Right. Right.
So the insight here was to say, we know all the read patterns that you're going to want to run. And so let's shred this document and store it in a way to serve those read patterns. And that was the
Okay.
approach.
Okay.
So what we did was use the collections in Cassandra,
Hmm.
which I know is a bit of a dirty word. They don't like classic Cassandra. Let's just go on and off disk as absolutely fast as we can. And not big on collections. They also have some issues with range tombstones and things, but
Oh,
we
sure. Sure.
overwrite them all the time and some things. And we think the functionality it gives us is great. And SAI indexes can index a map and a
Hmm.
set,
Hmm.
and they index it either on the keys or the values, but also on the entries in the map. So you can walk up to a map, like you can have a row in Cassandra that has a map of just string,
Hmm.
and you
Yeah.
can run
Yeah.
a query that says, find me, all the rows where the map has username equal to Aaron.
Oh,
That
wow.
works, right? So I could do that for doubles and I can do that for date times. And I can, if I
Mm-hmm.
had a set and I put all of the, um, the JSON paths that were in your document into that set, I could walk up to the CQL and say, find me all the rows where where is human exists in this set.
Right. Right.
So there's a combination there of the collection types giving you some denormalization. The SAI, which we've had at DataStax and be pushing to get into open source for a while now, just with the slowdown for 4 and 5.
Oh, right. Right.
SAI, which to us is a little bit old, but is new and covered in CEP 7.
Hmm.
That's how old it is. Going in there, some enhancements we'll bring into SAI. There's some enhancements that you'll also see coming into Cassandra. There's a CEP, it's called CEP 29, which adds kind of not an or and logical precedence tree into the
Right.
where
Right.
clause, right? So it can construct more complex where conditions. when you put these things together, you can, abuse Cassandra more than you would previously. We're clearly not designing this for the the sub-milli. We're not designing this for sub-millisecond performance.
Right.
This is about
Right.
functionality ahead of
Mhm.
performance. Still, if you want to get the absolute lowest latency and best performance, you are going to follow the SQL Cassandra isms of how you do your data modeling and
Yep.
things like that.
Yep. Yep.
But
Just kind of the way it's always been. Yeah.
yeah,
Yeah.
yeah, that's
For sure.
yeah. But that's we know those people. We've been those people over the years. You at Target and all this stuff.
All right.
We
Yeah.
yeah. This is about functionality. So those collections, SAI, and the enhancements that are coming to those enhancements in the logical operations you can put in the where clause that bring more complexity to
Mhm.
that, and then a chord coming to give us improvements in lightweight transactions. So you look at a
Right.
chord,
Right.
the CEP 15,
Mhm.
you'll see these really fancy looking like begin trans, do a read, have a condition, abort.
Yep.
Wow,
Yep.
abort. Remember when we started, talking to people about how Cassandra works and just explaining, well, there's no abort, right? If you write two things, well, yeah, one of them works, one of them doesn't. You're just going to have to live with it.
That's right.
You
That's right.
suck it up. Yeah. So Chord comes in with that, and that's the great part. But it also can be the implementation for the compare and set operations. So if you're doing, insert if not and update if, those operations can be driven by a chord. They'll be faster, and they're important because going back to that first comment about what's the experience that Node.js and Mongoose built,
Oh,
there
sure.
is something
Sure.
called like find one and update. There's a complex update structure that
Right.
you want to
Right.
do of like find the document, pull it back, make these changes and write it.
Mhm. Mhm.
LWTs we have to use there. So we're going to pushing Cassandra in ways that 5 years ago people would be, boy, that's stupid. I think Cassandra is getting better at being able to handle more complex functionality. And there are some trade-offs for performance just because it's physics and
Sure.
computer
Sure.
science, but they're only if you go down those paths and use those complexities.
Gotcha. Gotcha. Well,
Nobody
that
like
sure.
LWT scared people when it first started, right? Everyone was
It
like, "Oh,
did.
this is
Yeah.
so much slower than an insert."
Mhm.
But
Mhm.
look at the functionality that you get. So
Yeah. Well, that just all sounds amazing, and you're right. It changes Cassandra in, like some very, very profound ways. It certainly does open it up quite a bit, and yeah, yeah, I could see that. I could definitely see that improving again. That whole developer experience aspect where you're trying to build something, and maybe you need, a where clause that's a little more complex than what you'd normally run in Cassandra. And maybe you don't need 5 millisecond response time. That's okay. Yeah, yeah.
yeah.
Um, I was going to say too that with kind of all the hype lately that's been around vector search, have you looked at that at all for the API?
Probably be fired if I didn't. Uh,
Well, that's fair. Yeah.
yeah. Yeah. So we're exposing the power of Cassandra and the capabilities of Cassandra, but through this different API, right? And so vectors are a part of Cassandra.
Yep.
Yeah, I don't think there's any argument around that. Vectors are a part of Cassandra. It's in Cassandra 5, and it does a pretty good job of it.
Mhm. Yeah. Yeah.
I think one of the things we learned over the years is that it takes a long time to bed down a new database, right?
Yep.
8-10 years to get a bulletproof database. So we've got a bulletproof database by now, and adding capabilities to a bulletproof database is easier than building a new database.
Oh, absolutely.
Okay.
Yeah.
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 So yeah, you can, in your documents that you store, and if we got time, I think we might pull up just a little example of this. You can just store a vector. When you define your collection, you say, I've
Mhm.
got a vector, it's going to be this long. You can store your vector in there and then use that in the sort. So we've been working with Valeri, the maintainer of,
Oh, yeah. Yeah.
um,
Yeah. Of Mongoose.
yeah, yeah. So we work with him to see how we can make this just feel that it's at home in the Mongoose experience, in the Node.js experience. And yeah, same things you can do with Cassandra. Do these through the JSON API, do them using Mongoose, do them in JavaScript in Node.js, and it's very, very easy.
Oh, excellent. Excellent. Did you maybe want to show your code example now, just so we could maybe walk through some of that? And
Yeah. For those that take a step back, just for those that don't know Mongoose, don't know Node.js, Mongoose is an object document mapper. You define your schemas, runs in Node.js, and then you are just coding against it like an ORM you'd normally have. So let me share this screen here. I'm about to show some code that is talked about in a blog post that I think we'll put out with the socials and we'll include in the show notes or something like that. So there's a blog post that explains this thing. So this is a photo sharing site that one of our new starts made. See here, they're using Mongoose and they're defining a schema for a photo. He just uploaded all of his own photos. Here's where the vector is defined and he's just got a Mongoose validation on here because he's saying that this is a vector of size 1536. So when this collection is made, a configuration goes across. And then he also has one for, this is a vector based on the description. And we have one over here that's an embedding of the actual photo itself. And then when you want to go and store an image, we go down here, add photo. So we're just going, hey, I'd like to get a new photo object. And he sets up the properties on that. We're calculating the embedding here on the client side, storing that as the vector field, and then we just go save. So very easy way to get data in. This is the same here for searching by photo similarity. And then on this site, and again, we'll link in the blog post. We'll link the blog post here. We can do a search here by the content. And here we're adding in a sort by vector. And so we're saying photo.find in the category that's chosen and this vector description as to what sort of photo you want to get. So in this examples, I've used this and said, hey, can you find me photos of things that cows would eat? And it will come back with photos where the description has something about grass or things like that. We'll also use this for the search by photo similarity. So this is basically the same as Google search by image. So you upload a photo, we calculate a vector, and then we do a sort here, and we can pull back images that look similar to others using the embedding. So the great thing here is you've got all the power of Cassandra with a very simple way to interact with it, and a way that for Node.js developers feels very much just the way they like to do things.
One thing I noticed too is that, my Node.js is a little rusty, but, I did see, a few awaits in there. So is this working in like a reactive sense, or could you go a little bit?
So again, my JavaScript Node.js is a little rusty as well. So this example, it's a Next.js app. We're looking at the server side. We're looking at the server side controllers that the Next.js app is routing things to, and then making calls through Mongoose, which has got all the await syntax on it, and it doesn't have callbacks. Totally deprecated out of that now, and then that's calling us over on our side over the HTTP based API. And hitting our servers, making the call. So in that sense, it fully integrates into how Node.js developers are working, because Harry wouldn't let us do anything other than be very good at what we're doing. Pretty much. He knows quite a lot. So
I'm sure. Yeah. So now you have a talk coming up at the Cassandra Summit. You tell us a little bit about that before we get going.
Yeah, so that's in December, and
December.
I think the title is around super shredding and storing JSON. So it's going to be going through from a Cassandra perspective how we were able to do this, the new technologies we're relying on and the new technologies that we're going to bring in. And I think this is a win-win for a CQL as well. We've seen the CEPs there that we talked about. This is all about allowing you to do more complex things in CQL that allow you, that kind of remove a little bit of this partition-centric view of the world. Always, that's there. That, as we've seen, the highest performance will come from understanding how to make Cassandra go fast. But a bunch of this stuff is going, there are times when we need more functionality and a little bit less performance.
So my laptop is melting down a little bit here, and just real quick, Aaron, I just want to say thanks for coming back on the show. It's great to talk to you again, and hey, you've got an awesome name.
So your laptop is melting down, I'm going to guess, because I can't hear much of what you're saying at all. So I'm going to say, you said, hey, thanks, great, good to talk to you again. You've got an awesome name. And looking forward to the launch of the JSON API, which will be in September in the public beta, and then GA later in the year.
All right, everyone. Thanks for listening, and have a great day. And that's all for today. Thank you for listening to the Apache Cassandra Corner. Apache Cassandra is a registered trademark of the Apache Software Foundation. Thank you, and have a great day.